Good morning, students. So let us continue the design of Boolean functions using multiplexers. So in today's class we will discuss uh, how to deal with 8 is to 1 mux, right? How to deal with uh, design of Boolean functions using 8 is to 1 mux, but when the select lines are not matching with the number of inputs. So let us take an example. Implement f of a comma b comma c comma d is equal to summation of 1 2 3 7 8 10 11 12 using, sometimes they'll mention the specification of the mux, otherwise they'll mention the IC number, right? So in such cases you need to identify which mux he is talking about, and appropriate mux you have to use, right? So even the same function can also be designed using 4 is to 1 mux, that we will see it later. Okay, so right now we will discuss how to design this mux, this function using 8 is to 1 mux, right? So let me use 8 is to 1 mux, right? Sometimes they will also tell the mux that is IC number, which is 74151, right? So this can be done using two ways, as we have already discussed in the last class, that is using truth table and using a k-map, right? So what is the advantage of using k-map? K-map consumes less time. It takes less time to solve this problem, but when you go with truth table, then truth table will take more time, because you have to write all 16 combinations in this case, right? So I'll solve it both the methods, right? So whichever you feel comfortable, you can use it. Okay, so in exam, but in exam don't solve the same problem using both the methods. You take only one method and solve it. Okay, so if you have only 3 inputs, right, so in such cases we need to write only 8 combinations, right? But when the number of inputs increase, then the number of combination will also increase, right? So for this function we need to write total 16 combinations. Let me try with the first method using the truth table. Okay, so now there are 4 inputs A, B, C, D, right? So here he has not told about anything about which 3 inputs you have to use, because 8 is to 1 mux has total 3 select lines, right? So out of these 4 inputs, which 3 inputs you have to use as select lines, he has not told. So it is left to you, right? So here what I'll assume A and B and C are connected to select lines, right? So I am going to connect A, B, C to select lines, then I'll design this function, right? So where D goes, D will be connected to data line, right? So are connected to select lines. Okay, so remaining input D is going to appear on data line. Okay, so let us solve this, right? Write all 16 combinations. The writing of all 16 combination itself is an headache. Okay, so but I have already discussed 2 methods, so I'll discuss with the with I'll discuss both the methods and solve this problem, and let us verify whether the final result will be same or no. Okay, uh, 0 0 1 0 0 0 1 1 0 1 double 0 0 1 0 1. So here I wrote all 16 combinations, and according to the functions we'll fill the last column, that is 0. There is no 0 in the given function, so output is 0. Then 1 2 3 4 is not there, 5 is not there, 6 is not there, 7 8 9 is not there, so 10, then 11, this is output, right? 11 12 is there, there is no 13 14 and 15, right? So here I do not leave a space in between this, right? So what we will do, I'll erase this decimal numbers 11 12 13 14 and 15. Okay, Okay, so this is the truth table. And next, the last column is the data line to be connected to, right? Clearly you write data line to be connected to. Okay, so now uh, when I take 8 is to 1 mux, that is 74141 IC, 151 IC, right? So there are 8 data lines, D0 to D7. Okay, so a small d, that is fourth input, is going to appear on this data line, and other inputs are connected to select lines. Okay, so now there are three select lines: S2, S1 and S0. S0 is LSB, S1 is S2 is MSB, right? And out of these three, I'm going to connect A, B, C to select lines. Out of these three, small a is MSB, which is connected to S2. Remaining inputs are connected to. Out of these three, A is MSB and C is LSB. Actual MSB is LSB is D, but D is going to appear on select lines, sorry, data line. So C will be the LSB out of these A, B, C. So C is connected to S0, right? So now and it has two outputs. One is true form and second one is complemented form. So what I am writing here, I am going to take the true form output, that is F, right? So my output is going to appear on this output, this output line. Okay, now since there are three select lines, so how many combinations I can write with these three select lines? Total 8, starting from 0 0 0 0 0 1 0 1 0 to 1 1 1, right? So same select line combinations I have in this truth table, but there are they are available in pair, right? So see here, the first two combinations where A is equal to 0, B is equal to 0, C equal to 0, A equal to 0, B equal to 0, C equal to 0, right? So make one group similar to this 4 is to 1 mux, right? Similar to 4 is to 1 mux, right? Now I'll mark this because this input, that is D, is going to appear on the data line, right? So I'll mark it. Now I'll compare it with F, right? So if they are same, see, T is 0, F is 0, D is 1, F is 1. So they are same. So data line to be connected to what now? It is D, because it is F is same as D, right? Now second combination input is 0 0 1. So where it is available? It is available for these two combinations, right? So 0 0 1, right? So both the outputs are 1. So irrespective of the value of D, output remain as 1. So data line is to be data line should be connected to VCC or 1, right? Next combination is 0 1 0, right? Output is 0 irrespective of the value of D. So data line is to be connected to 0. Next 0 1 1, it is same. D is 0, F is 0, D is 1, F is 1. So data line to be connected is D. It has to be connected to D. Now 1 0 0, see here, D is 0, F is 1, D is 1, F is 0. That means F is complement of D. So what I should write? Data line has to be connected to D bar. Next 1 0 1, 1 0 1, 1 0 1, output is 1 irrespective of value of D. So data line is to be connected to VCC. Next the seventh combination 1 1 0, right? I'll mark it again. Okay, so 0 1, 0 1 and 1 0, right? F is complement of D, so data line to be connected is D bar. Next 0 0, output is 0, right? So now make this write these values on these data lines. So what is D0 here? This is D0, this is D1, this is D2 and so on. This is D3, right? So how we are going to identify? This is D3, D4, D5 and all, right? Depending on the values of A, B, C, right? So 1 0 0 is binary equivalent of 4, right? So D4, right? The subscript subscript is 4 and its binary equivalent is 100, so this is D4. 101, it is binary equivalent of 5, so it is D5. Next, this is D6 and this is D7, right? So connect now. D0 is connected to D, D1 is connected to VCC, or you just write 1. Both are same. VCC we are writing because when we are dealing with the analog voltage, right? So in digital we write it as we write VCC, or which is equal to analog voltage is 5 volt, and in digitally we represent it as 1. Next, D2 is 0, so either you write 0 or connect it to ground. It's left to you, right? Next, one more enable pin it has, so that needs to be grounded, right? So this is enable pin of 74151. Now D3 is connected to D, or you can short D0 and D3. D4 is D bar, or you take D and connect it to NOT gate. Output of NOT gate is connected to D4. Then D5 is 1, you can short D5 and D1, no problem. Then D6 is D bar. D bar you have already obtained here, right? No need to use again one more inverter. So same output, that is D4, you short it with D6, and the last one is D7 is 0, so connect it to ground, right? So analyzing part I'll leave it to you, right? So please analyze this circuit and make sure that it is working fine and you are getting the output right for all these combinations. So you take a binary combination of these values and apply to this design, and make sure that F is going to F will be fine for these combinations. For these combinations you should get what? Output is equal to 1, right? So I hope you understood this problem. Okay, next we will solve one more problem similar to this, right? So in next slide, right? So now again I will solve one more problem using 74151, that is 8:1 mux, right? So again we will take 4 inputs, and in next example I'll solve it using 4:1 mux. Okay, so let us take the second example. We will implement this given function. We'll implement this given function using 8:1 mux again, right? So sometimes in the multiplexer, select lines are also called as the address lines. So select lines as well as address lines are one and the same, right? So now in the last example I have explained it with an truth table, right? So now I'll explain it with an K-map, right? So I'll use a K-map, second method, and if you want it, you can use a truth table, but I feel it very lengthy writing a truth table, all 16 combinations and comparing, right? So instead of that I feel this 4 variable K-map, right? Because there are 4 inputs A, B, C, D, right? So I find this second method very easy because it takes less time, even though you have to identify the correct combinations of select lines and you have to group those cells, right? So instead it's left to you. If you're going with the lengthy method, then no problem, no issues. Okay, so but my duty is to explain both the methods, right? So whichever you feel comfortable, you can apply, you can go with that method. Okay, right? So fill these cells, right? Identify the cells first and fill those cells. This is 8, 9, 11, 10, 12, 13, 15, 14, right? So identify the cells. 4 you have to fill these cells. These cells should be filled with 1, 4, 5, 7, 8, 10, 12, 10, 12, 15, right? And remaining cells are filled with zeros, right? So now you have to identify again. A, B, C are taken as select lines. Again we will be having 8 combinations of A, B, C because these are 3, right? So now you have to identify where A, B, C is equal to 0, right? And which cells you need to group. right? See here, so this is A equal to 0, B equal to 0, C is equal to 0 here as well as here, right? So you have to group these two cells, right? So what is this? This is D0, which is equal to, both outputs are 0, no need to compare it with the D, right? So output is D0 is equal to 0. Next, uh, let me write those input combinations 0 0 0. Next one is 0 0 1, where A is equal to 0, B is equal to 0, these two, and C is equal to 1. C is 1 here as well as here, right? So again you need to group these two. That means D1 is equal to 0, because again grouped cells are having a 0, so no need to compare it with the fourth input, that is D. So directly you can write it as 0. Next combination is 0 1 0, where A is equal to 0, B is equal to 1, A is equal to 0, B equal to 1, and C takes 0 0. So 0 0 here, right? So that means these two cells, right? So what is this? This is D2, both outputs are high, so no need to compare, you can directly write it as 0. Next, 0 1 1, 0, A equal to 0, B equal to 1, but C equal to 1 here. So these two cells you need to group. Now they are different, they need to be compared with D, right? So D is 1 here, D is 0, F is 1, so output is 1, output is 0, so it is same as D. So you can write D3, D3 is equal to what? D, small d, right? So this is the data line and this is the fourth input. Next, next input is 1 0 0, 1 0, A is 1, B is 0, C is equal to 0 here. So these two cells you need to group. Right. Sorry, I made a mistake. This should be 1 1, right? So I made a mistake, sorry, I beg your pardon. Okay, so but filling of these cells are correct. I have numbered those cells properly, right? I didn't make the mistake, I made a mistake in this writing these two, right? So this is not 1 0 1 0, A equal to 1, B equal to 0, C equal to 0 0. So these two cells, right? So 1 0, compare it with D. So D is complement of these outputs, right? So what is this? This is D4, which is equal to D bar. Next, 1 0 1, 1 0 1, these two cells, 1 0 1, these two cells. Now it is D5, D5 is same, sorry, it is complement of D, so D bar. Next, 1 1 0, 1 1, A equal to B equal to 1 and C equal to 0, so these two cells, right? So again they are different, so they need to be compared with D. So D is 0, D is 1, F is output is 1, output is 0, so output is complement of D bar, sorry, D. So D6 is D bar, D6 is D bar, and the last combination 1 1 1, right? So these two cells need to be grouped and compare it with D. So D7 is D, right? So now design this using 8:1 mux, same as previous example. D1, D2, D3, D4, D5, D6, D7, right? And select lines are 3, S2 is MSB, S1, S0 is LSB. Out of ABC, A is MSB, then second one is B, and C is LSB, right? So what is D0? D0 is 0, right? D1 is 0, you can short D is 0 and D1. D2, there is D2, D2 is 1, D2 is 1, D3 is D, D3 is D, D4, D4 is D bar. So you can take NOT gate and connect output of NOT gate to D4. Next, D5, D5 is also D bar, so no need to use one more NOT gate, short D4 and D5. D6 is D bar, connected directly. D7 is D, so I'll connect D to D7, and this output is F, right? This is the given function, right? So analyze this using a truth table or whatever method you want to use. Okay, so in the next slide we will discuss how to implement this same function or different function using 4:1 mux. Okay.